Hi guys. In this video we are going to do a couple of problems off of this 9-3 practice problems worksheet. We already did number 1 in class together, so let's take a look at number 2 and number 3. If you haven't given this a try, make sure you try it. Those of you that weren't here on Friday, you might need to watch for the first problem, but then stop as soon as we're done with it so that you can try number 3 and see how you do. Okay, so let's start with problem number 2. It says, identify the limiting reactant when 4.68 grams of iron reacts with 2.88 grams of sulfur to produce iron 2 sulfide. All right, so first thing we need to do is write a balanced equation. So we have iron plus sulfur yields iron 2 sulfide. See if you can remember why it's iron 2 sulfide. Okay, so then we are going to be creating our BCA table. Before, change, after, and look at what we are given. We are given grams. Are we allowed to put mass, put grams in our table? Nope. So we need to convert those grams into moles. So let me shift my paper over a little bit. All right, so we have 4.68 grams of iron. And we're going to turn that into moles. So looking on our periodic table, 55.85 grams of iron for every 1 mole of iron gives us 0.084 moles of iron. Okay, then for sulfur, we have 2.88 grams of sulfur, 32.07 grams of sulfur from the periodic table, is equal to 1 mole of sulfur, and that comes out to, when you round it, 0.090 moles of sulfur. Okay. So, having that, now we have our moles. These moles can go into our table. So we've got 0.084 moles and 0.090. And we know that before a reaction has even had a chance to take place, there is no product. So we know that one. Okay. So the change, remember that's where we use X. Reactants are always decreasing because they're being used up. So we use a negative X for both of these. Do you remember why there's no number there? I'll fill you in. We have a complete balanced equation, so there are no coefficients. So it is just plain old negative X. This is going to be a positive X because as these get used up, this goes up, so it's positive. All right, so this time we're not concerned about our product for our final answer, and we can't put zeros in over here. What the problem is asking for is, in essence, which one of these is going to run out first. We are trying to find the limiting reactant. We want to know which one is our limiting reactant, is our final goal. Okay. So a couple of ways you can go about this. The easiest thing to do is usually look and see smallest number. Tens, not all the time though, tends to be the one that runs out first. I can kind of double check here, see how these both decrease by negative X. They're the same and these are kind of close together. So I am going to use 0.084 as my number. 0.084, and so that minus that gives me 0, so that one's run out. But let's see what happens with this one. So when I do the math on that, I get 0.006. That is a positive number. It means it is in excess. There's leftover. So that means for our final answer, iron is my limiting reactant. However, let's look at a couple of things that can help you as you are solving some other problems. So let's say that after you did this ended up being a negative number. That would tell you you chose the wrong one, because the one that's in excess is going to be a positive number. But this one is our excess. So let's say the problem said something like, how many grams of excess will you have? Then I can take these moles and I convert that back into grams. I could also figure out how many grams of iron to sulfide I could make. So there's a lot of different things I can work on, but that's the answer to number 2. All right, let's look at number 3. Turn this paper over. All right, so let's look at problem number 3. Problem number 3 says, identify the limiting reactant when 5.87 grams of magnesium hydroxide reacts with 12.84 grams of hydrochloric acid to form magnesium chloride and water. So first things first, we need to write a balanced chemical equation. So I'm going to go ahead and do it out. Pause this, do it yourself, make sure you're balanced correctly, and then start back up again. Okay, we've got magnesium hydroxide plus hydrochloric acid yields magnesium chloride plus water. Okay, if you remember some of our little tricks before, if you have hydroxide on one side and you're ending up with water on the other, I can write that as HOH if I want. It depends on where you stand with your balancing as to whether you need to do that or not. All right, when I balance this out, that's going to get a 2, and this is going to get a 2. Okay, so we're going to make our B, C, A table and look at what info we are given. We are told that we have grams for both of our reactants. So let's get our moles, do our conversions. So let me move my paper again. We've got 5.87 grams of magnesium hydroxide. Convert that out, 58.31 grams off the periodic table for every 1 mole magnesium hydroxide. And that yields, sorry I'm writing on paper again, that gives us 0.101 moles of magnesium hydroxide. Sorry, kind of sloppy. All right, and then for our hydrochloric acid, we start with 12.84 grams of HCl. That's 36.45 grams of HCl for every 1 mole of HCl. And that gives us 0.352 moles of HCl. Okay, so we can take these moles and plug them into our BCA table. So let me come on up here. All right, there we go. Okay, so I've got 0.101 and 0.352. I know both of my products are starting out as 0 because we haven't made it yet. My change, this one's going to be by a negative x. This one now, what is it? Yes, it is a negative 2x because of our coefficient. This one's going to be a positive x, and this one is a positive 2x because of our coefficient. Now we actually really don't care about these because they're not part of the problem. What the problem wants to know is which one of these two is going to run out first. We want to know what our limiting reactant is. Again, I like to look and see which one has the smallest number. It tends to work out. All right, so if I put in 0.101, 0.101 for x, do my math, this one's going to end up as a 0, and this one is going to end up as a 0.15, and it's positive, which lets me know that that is my excess amount, that's my excess one, and this is my limiting reactant. So my limiting reactant is magnesium hydroxide. All right, again, just a reminder, I could figure out, the problem might ask, how many grams of HCl will be left over? And then I could take these moles and convert them into grams. I also could figure out how much of each of these products I produce. So there's a lot that we can do with this. All right, guys, that should get you started on being able to solve some of these problems. I'll be posting answer keys later in the week. Try them. You can do it. You're able. Just take your time. If anything seems wrong, start over. Use pencil. I know I'm using Sharpie. Use a pencil. Go through, try them out. Watch the video. Coach Gambrell has videos. You have some videos down at the bottom of my page. Do what you can, put forth the effort, and you guys will conquer this and do awesome.